Hi, my name is Handason Tam. I'm a PhD candidate at the Chinese University of Hong Kong. I'm presenting PERT-GNN latency prediction for microservice-based cloud-native applications via graph neural networks. Microservice architecture structures an application into self-contained services that can be managed independently, allowing for flexible resource scaling. Our goal is to predict the end-to-end latency of an API call to a microservice-based cloud applications given their resource utilization and traffic loading. Top figure shows an execution trace for one API call with a simplified version in the top right corner. Predicting latency is difficult due to complex dependencies among microservices. They can invoke each other in different temporal orderings, which can be synchronous or asynchronous, and sequential or parallel. Graph neural networks can potentially be used to capture microservice relationships, but creating a graph that accurately reflects the abundance of information in execution traces is very challenging. Previous works have used span graphs to capture the calling relationships between microservices. It is a tree where nodes, the spans, and the edges are their calling relationships. However, it does not differentiate different execution patterns. For instance, these two execution traces are completely different, but they result in the same span graph, which is not ideal for predicting end-to-end delays. To address this issue, we introduced PERT graph, which represents events or milestones as nodes and dependent tasks as edges, which allows us to capture the complex relationships between microservices. This is the overall architecture of PERT-GNN. Our results show that PERT-GNN performs the best in estimating end-to-end latency in real-world large-scale microservice applications with less than 12% mean absolute percentage error, indicating successful incorporation of microservices dependencies in PERT graphs. The rest of the details are in the paper. Thank you for listening.